Arduino weighing scale. We have seen weight machines at many shops, where the machine displays the weight just by placing an item on the weighing platform. So here we are building the same weighing machine by using Arduino and load cell, having a capacity of measuring up to 1 kilogram. This limit can be further increased by using the load cell of higher capacity. The main component required to build this Arduino weighing scale is a sensor that can convert weight into an equivalent electrical signal. This sensor is called as the load cell. The load cell is a transducer that transforms force or pressure into electrical output. The magnitude of this electrical output is directly proportional to the force being applied. Load cells have a strain gauge, which deforms when pressure is applied to it, and then strain gauge generates an electrical signal on deformation. As its effective resistance changes on deformation, a load cell usually consists of 4 strain gauges in a Wheatstone bridge configuration. In this project, we will see how to build an Arduino weighing machine by interfacing load cell and HX711 weight sensor with the Arduino. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5-volt. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. HX711 weight sensor has 4 pins on one side and 6 pins on another side. 4 pins are VCC, ground, CLK, and data. 6 pins are A+, A-, E+, E-, B+, and B-. VCC pin is connected with the 5-volt pin. Ground pin is connected with the ground pin of Arduino. Data pin is connected with pin A0 of Arduino, and CLK pin is connected with pin A1 of Arduino. Red wire of load cell is connected with pin E+ of HX711 weight sensor. White wire of load cell is connected with pin E- of weight sensor. Black wire of load cell is connected with pin A- of weight sensor. Green wire of load cell is connected with pin A+ of weight sensor. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line, #include liquid crystal.h. Then we will declare the name of the used pins, in the sequence of RS, enable, D4, D5, D6, and D7. Data pin of HX711 is connected with pin A0 of Arduino. SCK pin of HX711 is connected with pin A1 of Arduino. Sample, float val, count, and I are 4 variables. Initially we set its value to 0. Void setup is a function in which we will declare the input and output pins. Here we are declaring pin A1 of Arduino, which is connected with SCK pin of HX711, as output pin. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Calibrate is a function which is used to calibrate the load cell. Read count is a function which will read the output data from HX711. In this function, we will first make pin A1 of Arduino, which is connected with data pin of HX711, as output pin. then we will give a high signal to it. Now we will give a low signal to the SCK pin of HX711. Now we will set count value to 0. Then we will make pin A1 of Arduino an input pin and read the data, bit by bit, coming from data pin of HX711. Data pin of HX711 will give total 24 bits as output data. We are saving these 4 bytes in a variable, count, which is an unsigned long type variable. Each time when we give a high to low pulse at clock pin of HX711, it will give a bit at its data pin. Bit could be high or low. We will start a loop that will run 24 times. In this loop, we will give a high signal to the clock pin. Then we will shift the count variable position by 1. Then we will give a low signal to the clock pin. W is an integer type variable. This formula will count the weight and store the final value in the variable W. Calibration is a function used to calibrate the readings. In this function we will put a 100 gram of weight on the load cell. To calibrate the sensor, if we put 150 grams in place of 100 grams, then Arduino will give the error of 50 grams in reading. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5 volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect a red, black, yellow and green wire at VCC, ground, data and CLK pin of HX711 sensor. Connect the red wire with the 5 volt pin, black wire with ground pin, yellow wire with pin A0 of Arduino, and green wire with pin A1 of Arduino. Now we will power up our circuit and test its functionality. Before using this machine, it is necessary to calibrate the load cell with Arduino. For calibrating load, we need to put 100 grams of weight at starting, when the LCD displays put 100 gram weight. Once 100 gram weight is kept over the load cell, calibration is done. Now simply you can put any weight for measuring with 99.9% accuracy. Now we will put various weights on our Arduino weighing scale. We can see that our weighing scale is giving approximately the correct readings. We hope you enjoyed the video and learned something from it. For any help in your project or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.